Studies that have discovered heavy elements following a bright gamma-ray burst from the merger of two neutron stars are significant for understanding cosmic processes and the formation of elements in the universe. These gamma-ray bursts, known as GRBs, are among the most energetic events in the universe, capable of releasing more energy in a few seconds than our Sun will produce over its entire lifespan. When two neutron stars collide, the collision not only produces a powerful burst of gamma rays but also generates gravitational waves, which are ripples in spacetime that spread throughout the universe. This process also leads to the production of a large amount of heavy elements, including gold and platinum, through a process known as the R process. The discovery of heavy elements following these events provides evidence for the origin of heavy elements in our universe. It is believed that these events are one of the primary sources of heavy materials in the universe, which are then incorporated into the formation of stars, planets, and ultimately, into the chemical composition of celestial bodies, including Earth. Studying gamma-ray bursts and their aftermath offers valuable insights into the physics of neutron stars, cosmic processes generating chemical elements, and the overall history of the universe. This type of research helps scientists better understand the structure and evolution of the universe, as well as the dynamics of matter and energy under extreme conditions.